We are on our fifth and final section of this first unit. Our topic is exponent rules. And basically the thought for the moment is, how do we simplify exponents? Oops. Need a pronoun in there. How do we simplify exponents? Some rules on simplifying exponents. First of all, this word simplify, we want each letter appears only one time in the result. So or each variable, and we want no negative exponents. Every exponent in our result should be positive, and our fractions should be simplified. And by fraction simplified, I'm talking about if we're given an actual number. So those are some key kind of rules for simplifying exponents. So we're going to look at 6 rules. A 7th one kind of on the side, kind of like we just did with our definition of simplifying, of how to deal with exponents. So the first rule is this. If I have the same base, I add, their exponents, okay? So when we are multiplying, we add the exponents. A couple quick examples. Let's say I've got x to the 3rd, x to the 4th, and x to the 10th. Then I add x to the 3 plus 4 plus 10, and I get x to the 17th. Let's say I've got 2y to the 5th times 3y to the 7th. The 2 and the 3 multiply, and then I have y to the 5th and y to the 7th, and I get 6y to the 12th. If you're ever not sure, a great strategy is to just start writing them out. I've got 3 x's here, I've got 4 x's here, and I've got 10 x's over there. And then at that point, I can just count them all up, right? So when in doubt, write it out. Our second rule. Let's say I have a power raised up to another power. In that case, I multiply those two. So a power to a power gets multiplied. Quick example. Let's say I have x. Oops, let me try that again. Let's say I have x to the 2nd raised up to the 4th. That means I have 2 or 4 groups of 2 x's. So I do 2 times 4, I get x to the 8th. If I have y to the 3rd raised up to the 5th, here's what that means. I have y to the 3rd 5 times. So it's y to the 3rd, but then it's 5 of those parentheses. Remember, when in doubt, write it out. Multiply the 3 and the 5, y to the 15th. Okay. Continuing on, kind of blending these two ideas, let's say I have something in parentheses being raised. Well, then that power essentially gets distributed in. X gets raised to the mth and y gets raised to the mth. So if I have a product, in other words, multiplication, raised to an exponent, bring the exponent into the parentheses. Here's what I mean. I've got 3y to the fourth. That 4, right? If you want to win in doubt, write it out. I've got 3y 4 times. But I have that 4 is going to hit the 3, and the 4 is going to hit the y. So I'm going to have 3 to the fourth and y to the fourth for a grand total of 81y to the fourth. Another quick example, let's say I have 2x squared to the fifth. That 5 hits the 2, and the 5 hits the x squared. I get 2 to the fifth, and x squared to the fifth, 32x to the 10th. Okay. Let's go a different way. We've done a lot of multiplying. Let's say I have exponents and fractions. And I've got a number on the top and a number on the bottom. Those get subtracted. If we are dividing, we subtract the exponents. Okay? Let's look at an example. Let's say I have x to the third over x to the second. X to the 3 minus 2 is just 1. Here's another example. Let's say I have x to the fourth, y to the eighth, over y to the third. When in doubt, you can write it out. 4 x's, they're just chilling. 8 y's and 3 y's. 3 of them on the top cancel 3 of them on the bottom, and that's where that 8 minus 3 comes in, and that's why it's y to the fifth. Okay? If we have a case, kind of like we did before, where we've got this xy and it is in parentheses with a exponent on the outside of the parentheses, that exponent gets brought into those parentheses. It is essentially moved, to the top and to the bottom. So it hits the x and it hits the y. If I have a fraction raised to an exponent, move to numerator and denominator. Okay. Here's a quick example. Say I have 2 over x to the fifth. Means I have 2 to the fifth and x to the fifth. And 32 over x to the fifth. Just another quick example real quick. Let's say I have x squared over 3y to the third. That goes in and I have x to the second raised to the third. I have 3 to the third and y to the third. For a grand total of x to the sixth over 27y to the third. When in doubt, write it out. You can totally write all of that out. I've got 2x's over 3y And since I'm raising it to the third power, I write it 3 times, and I can see how those combine to work together. Okay? The very last one's probably the toughest one, but we will accomplish it. If we have x, let's make it black. X to the negative n, or 1 over x to the negative n. Negative exponents move across to the other side of a fraction. I'm going to use this space over here to write that a little bit more. When we have negative exponents, we have to move them across the fraction bar to make them positive. So if we're going to highlight some keywords, negative exponents get moved across the fraction bar. So let's run through an example real quick. I got some extra space up here. Follow that arrow to get to some extra space for yourself. I'm just going to start with a simple one. X to the negative 2. Here's what I'm going to do first. I'm going to draw a fraction bar. X to the negative 2 is not currently in a denominator, but I am going to put it into the denominator. It's basically over 1 right now, and I'm going to bring it down. Now I've got 1 over x squared. Okay? Let's look at another example. Let's avoid some parentheses to start off with. I've got x to the third, y to the negative squared, x to the negative 2, y to the fifth. Now, you can totally use subtraction, but let's move everything to their homes first. Here's what I mean. X to the third is positive. It's just fine. It can stay put. In other words, it's not going to cross the fraction bar. Y to the negative 2. It's got to move. It's going to move down. X to the negative 2 down here has got to move. It goes across the fraction bar so that it can become positive. Y to the fifth. Y to the fifth gets to stay. Because it's positive, its exponent does not need to change. Remember, the rule at the end was no negative exponents. So we deal with negative exponents by moving them or having them stay. And there's our final answer.